Hey guys, today we're looking at negative exponents. We have essential questions right there. We're looking at how positive and negative exponents are related and how powers with negative exponents can be written using a positive exponent instead. Today we're going to be looking at these three sections in your notes. The first one, we're going to define these properties for negative exponents, and then we're going to try a few with the base of 2, and then finally you're going to be trying a few without me. All right, to start off, here's your properties. The first one is the negative exponent property for any non-zero b, so b is anything but 0. This is the property, b to the negative n equals 1 over b to the n. Then, for the negative exponent property for fractions, for any non-zero a and b, a over b to the negative nth power equals b to the a to the nth power. All right, we're going to be looking at exponential form and changing it to expanded form to figure out the patterns that arise when we use negative exponents. So when we look at this one, the first one we have is 2 to the 4th power, which is 2 times 2 times 2 times 2, which equals 16. And then the next one down, going down a power, so 2 to the 3rd is 8. 2 squared is 4, and 2 to the 1st power is 2. When you look at these, notice the patterns that come out. So we have 16 to 8, 8 to 4, 4 to 2. Each of these is divided by 2. So continuing on that power, 2 to the power of 0 is the same thing as 1, because 2 divided by 2 is 1. Anything to the power of 0 is 1. So then the next ones, when we're looking at these negative exponents, following that same pattern, 1 divided by 2 is the same thing as 1/2. 2 to the negative second power is 1/2 times 1/2, which equals 1/4. And following through the rest, 1/2 times 1/2 times 1/2 equals 1/8. Try the next two, hit pause, and try the next two without me to see if you catch the pattern. All right, for these last two, 2 to the negative 4th power, you should have gotten that that was 1 over 16. And then 2 to the negative 5th power was 1 over 32. Now, an important thing to know is that you can also write these as a fraction without the negative exponent. And so 1/2 is the same thing, 2 to the negative 1st power is the same thing as 1 over 2 to the 1st power. For 2 to the negative 1/2 power, that's the same thing as 1 over 2 squared. 2 to the negative 3rd power is 1 over 2 to the 3rd power. So by putting that 1 on top as your numerator, we're simply eliminating that negative exponent. So we're keeping it as a positive exponent. So this is 1 over 2 to the 4th. And 2 to the negative 5th is the same thing as 1 over 2 to the 5th. All right, getting a little trickier here, what I want you to do is try and rewrite each of these 5 different problems without negative exponents. Use the patterns and the rules that we just talked through and see if you can do it without my support. So hit pause and try this without my help. All right, let's check to see how you did. For the first one, we have 4 to the negative 3rd power, which is the same thing as 1 over 4 to the 3rd power. For the next one, we have 1 over 2 to the negative 7th power, and that one is the same thing as 2 to the 7th power over 1, which is equivalent to 2 to the 7th power. For the third one there, we have y to the negative 2nd power, and that's the same thing as 1 over y squared. For the third one here, we have the quantity of 2 over m to the negative 5th power, and that's going to change to be m over 2 to the 5th power to get rid of our negative exponent there. And then finally our last one there, c to the negative 8th power d squared. So for this one, our d squared is a positive power, and so we're not going to get rid of that, so that's going to still stay as d squared. But the c to the 8th power is now going to be in our denominator. And finally, I've got this for you guys. Not totally accurate, however, I thought it was kind of cute.